only mode.
Hello, and welcome to our live webinar with Robert Green, presented by Cadalyst. Today's topic is Demystifying GPUs for CAD Workstations. This is Nancy Johnson from Cadalyst. I'll be today's moderator. Our headliner today is Robert Green. As many of you know, a CAD management expert who's been sharing advice and expertise for more than 20 years through literally hundreds of Cadalyst newsletter and magazine columns, as well as through his book, Expert CAD Management, The Complete Guide, as a speaker at Autodesk University and elsewhere, and through his consulting work. Today's presentation is the third in Cadalyst's new webinar series featuring Robert. We've developed this series to provide a direct channel between Robert and you, the CAD managers who rely on his practical information delivered in a way you can understand and put to use immediately in your work. We hope you find value in this approach and enjoy today's event. Before I pass the baton to Robert, I have a few quick housekeeping details for you. First off, the slide presentation today will be accompanied by a webcam view of Robert, and you can control how that displays using the drop-down list at the top of your screen. Also, today's presentation will be recorded and made available to all registrants within the next 24 hours. You'll receive an email when the recording is available, and we'll have the slide deck available to share as well. Lastly, I want to let you all know that Robert's main presentation should last about 30 minutes. We hope you'll stick around for the Q&A to follow, which will run for approximately another 30 minutes or until we answer all the questions, whichever comes first. At any time, starting now, submit your questions using the questions pane that you find in your GoToWebinar control panel. Okay, so let's get to it. It's my pleasure to introduce our presenter, CAD management expert Robert Green. Robert, take it away.
Fantastic. Thanks, Nancy. And I'm going to go ahead and turn on the webcam. And I apologize, I have a face for radio, I'm afraid, but oh, there we are. Okay, so what we wanted to do in this particular webinar is to address a lot of the questions that I've received over the years about GPUs, or some people call them video cards, and what exactly it is that they do and how they work and which one you should buy, and et cetera. So what we want to do with this presentation is to hopefully give you enough knowledge to where you can go shopping intelligently and figure out what you're really going to need rather than having to rely on a marketing pitch from a manufacturer. So we'll go ahead and spin forward here and just talk about some of the topics that we want to cover. So basically, well, what is a GPU? What does a GPU do for your CAD applications? What are some of the key terms that you would need to know, so that buzz phrases and buzzwords and things that you might see in marketing literature? How much memory is needed? What are integrated graphics versus discrete graphics? How do I specify the right GPU for my requirements? So these are just some of the typical things, and that's what we'll try to focus on in the presentation today. Let's start at the beginning. What is a GPU, or a graphics processing unit? Well, a little bit of an overview, and then we'll look at some diagrams. Basically, what the GPU does is it unloads or offloads the graphically intensive tasks that your CPU would normally have to handle. So if we think about a CAD application, you know, you're doing a lot of things like when you're building a building in Revit. You know, you're asking the CPU to figure out where the walls are and how to compute intersections, all these types of things that are arithmetically intensive. That's what your CPU does. But also, in order for the human being to see what's going on, a result has to be sent to the screen. And that task is what the GPU is going to handle. So the architecture of a GPU really is quite different than your CPU. The CPU is a very versatile thing it's handling all sorts of tasks. It's handling your operating system, where files are located, how to open and close things, how to perform the functionality in your CAD tool. Whereas the GPU It's a one-trick pony. All it does is paint pixels onto your screen. And therefore, the architecture of a GPU is somewhat different than your CPU. Diagrammatically, let's look at it this way. If you're running a CAD application, whether that's AutoCAD or Revit or SolidWorks or whatever it is, there's a whole lot of application code that's being handled by your CPU, but there's only a relatively small amount of functionality that's sending images to your screen. And that non-compute intensive functions are what's handed off to the GPU. So the CPU and the GPU have a working relationship, and the CPU moderates what is sent over to the GPU. So I know their CPU and GPU sound similar, but they really do different things. So this is really a way to offload graphically intensive tasks onto the GPU so the CPU has less to do, allowing your CAD application to operate even quicker. So one of the fundamental differences is that the CPU, or the central processor that's in your workstation, it handles all kinds of tasks, and it tends to handle them sequentially. If we think about a CAD application, it's opening a file. It's then performing editing upon that file, writing it back to the disk, all that stuff that happens to the CPU. But as it's occurring, what you see on your screen is being handled by the GPU. And since the GPU's only job is to calculate what pixels will look like and send it to your screen rapidly, the GPU utilizes hundreds, if not thousands, of parallel cores. It is essentially a very task-specific parallel computing device. And that way, it can send information to your screen rapidly, much more rapidly than a CPU could ever do. So I hope this kind of clears up the architectural differences and explains to you how your CAD application makes use of the CPU and the GPU at the same time. So, conclusion. One thing that we can say immediately is that the more your application software needs high resolution and or motion-based graphics is largely going to determine what sort of GPU, that is how powerful it will be, that you're going to need to run that application well. Obviously, the more high resolution and the more motion-based graphics you have, the more powerful a GPU you're going to need. So let's jump into a question that I do hear a good bit, which is, what is an integrated graphics GPU versus a discrete GPU? You may have seen this in some of Intel's marketing literature, and therefore I think it's worth our while to go ahead and define it briefly. Integrated graphics, it's a GPU that's actually part of the processor. So when you're specifying an i7 or a Xeon chip, CPU chip for your workstation, the GPU can be part of that processor. And since it's integrated into or built into the CPU chip itself, it tends to be lower cost, yet it is less powerful than a discrete GPU or an add-in card, which we'll be looking at next. The integrated GPU shares memory with the CPU, so the system RAM, if you will, is being parceled up and shared so that the GPU can have some memory to do what it needs to do, as opposed to having dedicated memory, which discrete graphics or GPU boards have. Now, another thing to consider is that if the GPU is built into your processor, it's not going to be upgradable. You can't go in and pull a section of your CPU chip out and upgrade it with something else. So if you do go with integrated graphics, you need to make sure you're happy with what you have at this point, because it won't be upgradable other than adding in a discrete GPU card at some later point. So where do integrated graphics work well? Well, they tend to work pretty well for 2D CAD, so this would be something like a MicroStation, AutoCAD, AutoCAD LT, or someone who's doing light-duty 3D modeling, not modeling entire buildings, but modeling certain parts of the building or creating parts in a mechanical CAD application, for example. Not a lot of visualization, not a lot of real-time video going on. just basic CAD work. These are the types of things that integrated graphics can support and support pretty well. Now, when you're looking at a processor, for most cases, CAD workstations are going to use either an i7 or some flavor of an Intel Xeon processor. Not all of these processors have integrated graphics, but a decent chunk of them do. So if integrated graphics is something you want to pursue, you need to make sure that it's actually on the CPU chip that you're purchasing. Let's flip over to the other side of the coin, which is a discrete GPU. We've got a picture there of a board that you can just kind of look at for reference. A lot of times you'll hear these called a graphics card. A discrete GPU, it's a standalone add-in board. It goes into an expansion slot in the workstation, taking up space, consuming power. We'll talk a little bit more about those parameters. The nice thing about a discrete GPU is that you can shop for widely varying amounts of cores and dedicated memory and in essence buy the performance level that you'll need for your applications. So a lot more flexibility here than integrated graphics, but comes at a price in terms of real estate and money. Of course, varying resolutions and frame rates and all these different parameters, varying connection ports, quite a lot of things that you have to think about technically when looking at a discrete GPU. These can be from a few $100s to several $1,000 depending on what you're trying to do, what kind of application software you're running. So the main players in the market are going to be NVIDIA and AMD. So in NVIDIA, you may have seen brand names like Quadro or GeForce, or in AMD, you might see things like Radeon or FirePros. These are the main players in the industry, and honestly, NVIDIA dominates. They're something like 70 to 80% of the market, depending on which survey you read. So the conclusion that I would like to make in our initial exploration of this is that integrated graphics are something that may save you money if your graphics needs for your applications are relatively simple. So principally 2D only CAD users could now get an integrated GPU with their computer, with the workstation when it's delivered, and you're going to save money from several $100s, maybe up to $1,000. And you can always add a discrete GPU later if it turns out that your user outgrows the capacity of the integrated graphics. But this is a good way to kind of get in at an entry level and save some money. So if your budget's tight, integrated graphics might be something you could consider. Now we started throwing out some buzz phrases there, and I want to go ahead and cover this because I didn't stop to define every acronym and things, but what we're going to do is just start taking a look at some specification sheets for some NVIDIA graphics GPUs, and we'll just kind of explore it as we go through this, and I'll endeavor to go through it fairly quickly. So here what you can see on the left-hand side of the screen is that we have all the kind of core stats for this particular NVIDIA graphics board. And the first thing that I want to turn your attention towards is the concept of cores and the memory amount and architecture, because these things are crucial for your understanding. Most GPUs are going to give you a number of graphical cores and the amount of RAM, typically expressed in gigabytes, that is on board this GPU. Now here we can see this is an 8 gigabyte GPU, and there's some more things that we can look at here when it comes to the memory. You can also see that this one has 1,792, or very nearly 1,800 processing cores that will be operating in parallel to stream images to the screen. So this is a fairly robust graphic. It's actually a Quadro 4000 series, a fairly robust GPU. And what we can look at here in terms of the memory, okay, well, we have 8 gigabytes of memory, but what exactly does that mean? What we see here is that we have a 256-bit memory interface. Now, the larger that number, the wider the memory interface, and therefore the more memory paths between the CPU and the GPU. The higher the speed, or the higher the width of that memory interface, the faster your CPU will be able to unload graphics onto the GPU. So higher is better when we look at the memory interface. Furthermore, we can look at the bandwidth, which here is reported at 243 gigabits per second, and that's an indication of how much or how quickly information can be streamed back and forth between the CPU and the GPU. It's not just the width of the memory interface, it's also the speed at which the cores are operating. So the higher that memory bandwidth, the better. Most GPU manufacturers are aware of how many gigabytes of memory it's going to take to optimally support the number of cores that are on the GPU. So that's why you tend to see relatively few options, and a lot of people think that the more memory you get, the more expensive the card is. That's not really true. The card is getting more expensive because it has more robust memory, wider bandwidths, and wider memory interface capabilities. So you're essentially getting fancier hardware, and that's why the cost tends to go up. So the question I usually get is, how much memory do I need? Do I need a 4 gigabyte GPU? Do I need an 8 gigabyte GPU? And that's really the wrong question. The right question is, how much performance are you going to need? Because that will dictate the number of cores, memory, and bandwidth that the GPU will need to deliver to you. So somebody who's doing basic two-dimensional AutoCAD with no video or rendering whatsoever is not going to need much performance, and therefore is not going to need a very high memory GPU. But somebody who's designing complete buildings, they're tumbling around this building and doing real-time viewing, yeah, they're going to need more. So how do I gauge my needs? Well, the more graphics you use, the more video you need, the more of these things that are running at the same time, the higher your performance needs will be. So in these particular cases, where people are using large models, a lot of visualization, I generally do recommend buying up, because when you really get into it and very demanding towards the ends of projects and everything has to run at one time, buying up to a higher level of GPU is going to protect you against slowdowns. Let's look at a couple of other parameters which are worth noting. The interface for the GPU and the power consumption for the GPU. What we can see here is the difference between a NVIDIA 4000, Quadro 4000 on the top, and a Quadro 8000 on the bottom. So we can see that the 4000 on the top is going to consume 105 watts of power, and it installs into a single PCI Express slot. Whereas the 8000 on the bottom, it does require 2 interface slots, if you look there carefully, and it will consume 235 watts of power. So this means that purchasing the right GPU for your needs isn't just about the GPU, it's about the workstation case, power supply, and cooling capacity that will have to be there in order for you to install it. So you can't buy a super miniature workstation and put one of these Quadro 8000s into it. You won't have the available power supply or real estate that it will take to support it. So do keep that in mind. In general, as the GPU, the power, the ability to handle greater graphics loads, you're going to see the power requirements and the amount of space required in the case go up. And since the power requirements of these higher end GPUs is relatively high, that means you're going to need better cooling. So you want to make sure that you have larger cases for more internal air volume and better fans to dissipate that additional thermal energy. Another parameter that we need to consider is video resolution. So typically, most of the GPUs that you're going to be looking at today are going to support 4K. And you can see here in the specifications for the Quadro 4000, it supports 4K streams. Sometimes you will see up to 5K supported, but not in all GPUs. A refresh rate of 120 hertz is desirable because many of the monitors that are in use now can support that 120 hertz refresh rate. And the higher that refresh rate, the smoother, the higher, or the crispness, if you will, or the motion that you're going to detect, especially from moving video, is going to seem better. Now, if you do have standard HD, a 1080 formatted HD monitors at this point, don't worry. These GPUs will automatically step down, not a problem. What you want to do is look at the higher video resolutions to gauge what your needs are going to be for your application software. Now, we know what kind of resolution to look for, but what type of monitor is it sending that resolution to? Typically, most professional GPUs now utilize Displayport or DP standard connectors. Once in a while, you might see an HDMI connector, which is great for plugging into flat panel TVs, can sometimes be excellent for plugging into presentation monitors that you may have in a conference room, something like that. And occasionally you may see Displayport with audio, which is essentially like HDMI because it's streaming video and audio down the same wire. Again, that can sometimes be quite useful for conference rooms, or if you do lecture speaking at conferences, it can be nice to have everything consolidated into one connector there. If you do have monitors that have only HDMI ports, you may have to wind up getting DisplayPort to HDMI connectors. Most CAD people that I know use 2 monitors. Occasionally, maybe 3, but most of us tend to use 2. And almost all of these professional graphics processors are going to support at least 2, if not more. What we can see here on the Quadro 4000 is it actually supports 4 concurrent monitor connections. And at 4K, 120 hertz refresh rates, that's actually quite a lot. Personally, I use 2 monitors. Don't really know what I would do with a 3rd one. So, conclusions we can draw from this. The resolution that your monitors today have and the resolution that you may want your monitors to have in the future are going to somewhat dictate what you purchase for a GPU. It's almost 100% sure that any older HD monitors you have will tend to work with any newer GPU. The question really is the GPU going to support what you want to use in the future? Will it be able to support 4K resolutions at 120 hertz? So those are the things you want to be looking at for obsolescence prevention in the future. Let's dig a little bit into this, which is what APIs and drivers are supported by the card. Now, typically, professional GPUs that support Windows-based CAD tools are going to use DirectX. For applications that can run not only on Windows but on iOS, so like a tablet or an Android device, as well as Windows apps, a more generic standard called OpenGL or Open Graphics Language is also employed quite a lot. So it's potentially possible that your application, your CAD application, may use both of them. So these are kind of the 2 graphics standards and driver standards that you want to be sure are present on anything that you're buying for a CAD workstation. Now, how do you know? Well, you check the software documentation for what protocols, drivers, and versions they need. And the watch out would be, sometimes if you're running very old versions of software, it may not recognize, that software may be old enough that it's using DirectX 9, and it may not recognize the DirectX 11 that's on your new GPU. So in cases like that, you may have to actually download some updated drivers from, in this case, NVIDIA, or from the graphics manufacturer, so that you can get your older software to recognize the newer GPUs. Just word of warning there. What I would recommend that anybody do is to try and find the Goldilocks zone for your GPU requirements. So purchase the GPU that is going to meet your monitor and resolution needs for the next several years out. So will that be 4K? Will it not be 4K? That establishes a baseline so that you get the right GPU rather than overkill or overspending. It is sometimes advisable to go ahead and buy up one step, spend a few $100s more to get the next step up, just simply to avoid obsolescence. Your choice would be to find out that the GPU you have today is inadequate for your future needs, so you may have to remove your current GPU and put in a new one. Sometimes buying a step up is more economical than upgrading later. One thing that we did not see on the specifications of the GPUs we looked at, that is something that you read a lot about, is frame rate. And one of the places where frame rates comes up a lot now is in the concept of using machines for virtual reality. This seems to have caught quite a lot more attention within the last year. So I'd like to at least cover the basics there so that you know what to expect. Reasonable first question is, what is frame rate anyway? Well, it's the number of frames per second, or FPS, that the GPU can actually send to your screen. There's a few things that you can know trend-wise here to be aware of. That the higher the frame rate, the higher the frames per second, the smoother the perceived video you get on your monitor. However, as you go to higher resolution, so as you go up from a 1080 HD up to a 4K HD, the number of pixels actually goes up by a factor of 4. Twice the resolution means 4 times the pixels. So the higher that resolution goes, the harder your GPU has to work, and therefore the frame rate tends to slow down as you do this. That's why so many gaming machines you'll see run in a 1080 HD mode rather than 4K. It's simply to get the higher frame rates out of the GPU. The more monitors you use, the more processes you run on your computer at the same time, is going to slow the frame rates down, simply because the GPU is having to work harder. And it's having to do more juggling, and it's sending things to 2 screens rather than 1. For realistic, immersive video, like a virtual reality type of playback on a monitor, 30 frames per second is considered to be the gold standard or the tipping point. If you go much below 30 frames per second, you start to perceive kind of a glitchiness, or not, it doesn't look like broadcast TV anymore. Just if you are slightly below 30, it doesn't look too bad, but if you start getting down into like 15 frames per second or something, you really, really notice a difference. Now, if you're going to do virtual reality on a headset, you know, like some of the HTC equipment or the Oculus equipment, 90 frames per second is recommended, because operating much lower than 90 frames per second with a screen that's that close to your eyeball is going to start to cause nausea or disorientation. And you think, well, that's alarmist. I've seen it happen. I've seen people take the headsets off and fall over. So that's reality. Now, the good thing about using the headsets is that the screen in front of your eye is much smaller, much lower resolution, so the GPU doesn't have to work as hard in order to get 90 frames per second to it. But still, it's a pretty high frame rate, and it requires a pretty substantial GPU in order to meet these goals. So when you start seeing things that say, this GPU is VR ready, basically what they're saying is it's a high performance GPU that is going to be more likely to meet these types of frame rates. So why is it when I look at the specifications for a GPU that they don't tell me the frame rate? Well, because there's so many variables to consider in terms of what workstation are you going to have, what CPU do you have, what applications are you running, how many things are running at one time, what resolution monitor are you using, how many monitors. There's a lot of variables. So they're really not going to list it. What I recommend is just do a Google search, put in the manufacturer model number, in this case NVIDIA Quadro 4000, put in the application software like 3ds Max, and then put in frame rate. execute your search and watch what comes back. What you're going to see is results from a variety of sources. You'll see some things from like Tom's Hardware or trusted reviews. You'll probably see a lot of posts in your specific, for a 3ds Max, for example, produced by Autodesk, so you'll see a lot of things in their user communities that are valid. You may see reviews in PC Magazine. You'll get a variety of sources coming back, and I would just tell you to read through that, because you'll see basically what the consensus is. You know, if this is an inadequately powered GPU for 3ds Max, you'll see people say that. So don't necessarily trust something that's coming out from the manufacturer. Do a Google search, dig into the user communities out there, and you'll find out a little bit more. So one thing that I would say is that if VR is something, virtual reality is something that's going to be a principal concern for you down the road, you probably do want to buy up into a higher performance VR-ready GPU. It does cost more, but you don't want to arrive at the point where you're trying to do VR and your frame rates are inadequate to do the job. Here's a question I get a decent bit. Should I buy a professional or a gaming GPU? Well, the answer to that question is, what are you doing on your computer? If you're a CAD user and you're modeling buildings or parts or doing 2D annotation in AutoCAD, then that tool is much more likely to run on a Windows-specific workstation. It's much more likely to use DirectX for its driver protocols. Therefore, it's much more likely that you would want a professional GPU. So in NVIDIA parlance, they call that a Quadro. And in AMD parlance, they call that a FirePro. The reason is because these are optimized for and tested extensively with CAD applications. If, however, your principal tasking is to do visualization or to produce animations or videos or do video editing, then you're much more likely to be using applications tools like something from Adobe, for example, or Camtasia. Those are much more likely to use OpenGL, and you're much more likely to gauge the performance of that software based on frame rates. And higher frame rates with OpenGL are exactly what gaming GPUs, which NVIDIA calls their GeForce series and AMD calls Radeon. That's much more what gaming GPUs are optimized for. So that would probably kind of answer your question. And here is kind of an interesting side note that's particularly valid at the moment. Right now, there's a lot of these Bitcoin and cryptocurrency mining computing farms in operation. And one of the things they use is GPUs, high-performance GPUs, with lots of cores and memory. This has meant that gaming GPUs are highly sought after right now. It's actually led to rationing. It's led to price increases. So the old kind of thought was that professional GPUs are more expensive than gaming GPUs. That line is really blurred right now and is not necessarily true anymore. So professional GPUs for CAD applications are pretty much cost competitive with better gaming GPUs at this point. This kind of leads us to one of the final things that we're going to talk about, and then we'll wrap up and get to Q&A, which is the concept of ISV certification. You may have seen that acronym and not really know what it meant. Well, professional GPUs are validated by independent software vendors. So we mean the CAD manufacturers. This is Autodesk, it's Dassault, it's Bentley. They tend to test their new products with professional GPUs like Quadros or FirePros, and they make sure that the driver software and everything that's happening between the CAD software and the GPU is correct. So basically, they're certifying that that GPU hardware is going to work. And over time, they are much more likely to release driver updates. As CAD software evolves, you'll see professional GPU driver updates over time. Basically, professional GPUs are more optimized for CAD tools. They're updated more frequently, and you're less likely to have a glitch or a problem. This is not necessarily the case with gaming GPUs, because gaming GPU manufacturers don't spend any time trying to figure out if they run well with AutoCAD or Revit. So good luck if you have a problem, has been my experience. That's where I've tended to recommend professional GPUs for CAD users. Okay? What it really comes down to is that the software developer is going to tell you which GPUs they've tested with and which ones they will ensure optimal performance and compatibility with. So go to your software manufacturer's page, type in a search parameter for GPU, and look at the things that they have warranted as operating correctly. That's essentially what ISV certification is. Couple minutes over budget here. Sorry, we just had a lot of stuff to cover, and I tried to go through it not too quick, but we'll wrap up now and get to Q&A. So, final thoughts. There's a lot to consider, really, but knowing your needs is paramount. What resolutions are you going to use? What type of monitors are you going to buy in the future? How much visualization are you going to do? Will you be doing animations, fly-throughs? Will you be using your workstation to do VR presentations in a conference room? As you think about these parameters, and as your requirements go up, and up, then the power level for the GPU that you want to buy will go up as well. Try to buy what you need today, or perhaps one step higher than that to prevent obsolescence. One of the nice things about a GPU is if you outgrow it, you really can unplug it and upgrade it, the workstation, with a better or faster GPU at some point in the future. You're not boxed in necessarily for the life of the workstation. For 2D CAD, principally AutoCAD MicroStation, you may want to consider integrated graphics because they may very well be all the performance that you're going to need, at least for now, and you can plug in a discrete GPU card later. For high performance CAD, think professional discrete GPUs. That has not only to do with performance, but it also has to do with longer term reliability of drivers and making sure that the software manufacturer is actually testing with that GPU to minimize your possible downtime that you could experience in the future. If pure video playback or VR is all you're going to care about, you may want to consider some high-speed gaming GPUs. If that is a dedicated VR station, that may be what you need. But if you're going to be running CAD on the workstation, stay with professional discrete GPUs. Okay, so I did go about 4 minutes over. My apologies. Nancy, what have we got coming in on the Q&A?
Okay, Robert, we have lots of questions coming in, so thank you for that presentation. I think you answered a lot of the questions as we were going along, but there's several other specific things that are coming in. Just as a reminder to everyone watching and listening, if you have a question for Robert, go to the questions panel that's on the in the GoToWebinar interface, and you can submit that, and we'll be fielding those until the end of the presentation here in about 20 minutes or so. Okay, so Robert, you gave lots of great general advice about determining what you need in terms of processing in graphics and how to kind of translate that to the software you're using, et cetera, and to get good performance there. But, and I think this is natural, that people are asking specifically for some direction. You know, I use XYZ software, what do I need? So could you give us, especially for some of the most popular CAD applications, the latest versions of AutoCAD, Civil 3D, Revit, maybe some SolidWorks, I saw Navisworks mentioned. Could you equate that general advice or translate it into some specifics, and maybe that'll help people even better apply the general information that you've given us already?
Yeah, I'll do my best. So if we look at some of the NVIDIA professional graphics boards, if all you're doing is using two-dimensional AutoCAD, then there's really very little requirement that goes above integrated graphics. But if you're going to be doing AutoCAD plus or rendering plus maybe some sort of animations, or or you're using higher resolution outputs, then it kind of seems like the NVIDIA Quadro 2000 is a good balanced place to be. It'll support multiple monitors. It's not going to be over the top in terms of power. It's not, but it doesn't cost that much either. It's not going to be robust enough to do virtual reality playback, but it should serve those types of users just fine. If you start getting up more into 3D, so we're talking about a SolidWorks or Revit, things like that, where you're using large models and you really want to see how they look graphically. So you're using materials, you're using shading, those types of things. That's a more aggressive application. And going up to the NVIDIA 4000 series is probably worth your while at that point. Once we start getting over the NVIDIA 4000 series, that starts to be something that's more for people who are going to have real, fly-throughs, walk-throughs. They're going to be producing animation type products. That's largely where that starts to happen, and interestingly enough, that's where the pricing starts to go way up too. So I would say, almost categorically, if you have a 3D CAD user with modest requirements, you could probably be safe with an NVIDIA 4000, and that would probably support them well over the life of the workstation, let's say 3 years out.
And what about, Robert, some of the applications that kind of cross between CAD and graphics? One of your listeners asked specifically about like 3ds Max, which is a visualization program, Recap, which is, I think, point cloud processing, InfraWorks, those kinds of that are model-based but graphics intensive.
Yeah, those are the applications that kind of blur the lines. And again, we get into probably like the NVIDIA 4000 series. Will support most of those workflows pretty nicely, unless the models are just getting huge. So if we're talking about something where you have fully coordinated BIM models and there's tons of stuff to be rendered, then that may be a case where you'd need to get up and above the 4000. For the most part, what I say is, if you're a designer, if that's what you're doing on the computer, then you probably don't need a super high power GPU. But if you're producing a lot of things that move, where you're orbiting around the geometry, where the graphical appearance of it, colors, materials, depth of field, being able to put things like, grass or sky or things like that behind it, then yes, that points to a higher powered GPU.
Got it. Thank you. This is a good question. What suggestions do you have for testing graphics card performance?
Well, if you can possibly do it, what you want to do is work with your workstation provider, and you take your first guess at what you think will be adequate. But then if it's not, then try to make sure that you can swap to get a higher powered one if that's what it seems like is going to be required. You can just simply go buy one, get on Newegg or whatever, buy one and plug it in and see how it runs. Worst case, you may have to pay a restocking fee to return it, but at least that allows you to do some research. One of the things that I recommended was to do a Google search with the parameters of frame rates. You could also do a Google search when you're talking about performance. And there's actually a lot more information than you think out there. If you were to go into some of the, say, the Autodesk user community, Augie site, or look at the Autodesk tech support or, communities section on their website, there's tons of pieces of feedback on there where people will tell you, we had this card, these are the model sizes we're using, and this is what we experienced in performance. So while you ultimately may have to buy it and try it, there's quite a lot of information out there if you go turn over enough rocks. You should be able to be fairly well educated before you buy anything.
What about, are there any benchmarking tests? Or could you just run like the Cadalyst benchmark or any other benchmark using different GPUs as the basis for the test to compare the effects there, different GPUs?
Yeah, you can in fact run different benchmark or the same benchmark model, same benchmark version of software, run those with different GPUs. There's, of course, there's SpecMark, there's various, industry standards, but the problem is none of those, in my experience, are really geared towards CAD. They're more geared towards games. They're more geared towards software like typically Adobe Suite, where people are graphic artists or animators. It's more geared to that. There's not nearly as much industry-specific benchmarking for CAD. So, what I typically do is let's get a real worst-case model. Let's load it up on the software in question, get out a stopwatch, see how long it takes to perform this function, and that's in essence what we do with the Cadalyst benchmarks.
Got it. Thank you. Could, so many to choose from. Will a processor with integrated graphics support dual monitors?
Almost always, yes. And some of them can even support 4. Depending on the processor you're looking at, you'll see there will be different buzz phrases and different version numbers. Like you'll see integrated graphics 530, you'll see integrated graphics 630. So it just kind of depends, and you have to look. The other thing is the workstation manufacturer is only going to put so many connectors in the chassis of the workstation. So just because an integrated graphics chip supports 4 monitors in theory, doesn't mean the workstation will come with 4 monitor connection points. So kind of have to pay attention to the workstation documentation there.
Okay, great. So you want to look at the number of connectors in your workstation as well as the specs of either the discrete card or the integrated graphics. Correct. To figure out if it's going to support your monitor situation.
Correct.
Okay, good. So hey, what about working in the cloud? Does that eliminate all your concerns about graphics performance because you're not relying so much on your workstation to do the graphics work?
Well, I mean, if the application is actually hosted, then yeah, I guess ultimately the frame rate and the graphics is being done on the other side of the cloud connection and sent back to you. But you may have data that resides in a cloud location that's actually being locally processed on your workstation. And in that case, you still do care about the power of the GPU. Now, one thing about a lot of cloud tools is that they're striving to be compliant. They want to run on a Mac browser just like they want to run on a Windows browser. So they tend to be more geared towards OpenGL, whereas Windows-based CAD tools are more geared towards DirectX. So if you're working exclusively on cloud applications, that may even be a case where you want to look at OpenGL performance and perhaps even a gaming GPU. But if you're using desktop-based CAD software, I still think you should worry about it, and I still think you should tend towards a professional GPU.
Okay. What about when you're looking at your GPU setup on a desktop workstation versus a mobile workstation, is it safe to assume that if that you're going to get, well, does the platform have any effect on the GPU performance, the quality of the GPU, or do you just need to look at the specs?
Well, yes. I mean, you need to look at the specs, and typically the higher cost that you're encountering in a mobile device, whether it's laptop or mobile workstation, you'll be ranging from anywhere like integrated graphics on the lower end up to maybe something as high as an NVIDIA 2000 mobile series. Generally speaking, you're never going to get the high-end GPU performance in a mobile device that you would get on a desktop. And the other thing is the desktop, you can tear a GPU out and upgrade it, whereas when you buy a mobile device, it's integrated onto the main board and it's not really upgradable. So when it comes to mobile, you're losing some flexibility and you won't be able to achieve the high upside power that you could in the desktop. Got it.
Here's a question about vGPU. That's new to me. We didn't really touch on that. He says most environments are moving toward VDI and looking at solutions like NVIDIA's Tesla or Pascal cards. What are your comments?
Yeah, I think the jury's still out. So if we start moving towards an architecture where your CAD applications reside on a machine somewhere else, in a data center at an Amazon server farm or something like that, then that point is well taken because the GPU resides there on the other side of the internet connection. But those graphics are now being passed back and forth in an optimal manner to your machine. So these newer generation of GPU cards are more optimized for that type of interaction. Now, I don't see much of that in the field yet. It's coming, and it would be great if the performance lags and latency and everything would allow it to really function, but I'm only seeing it in a fairly small section of companies at this point. So I'm not too alarmed. I'm still thinking that over the next 2 to 3 years, we're probably still buying GPUs for workstations that are doing the processing at the desktop.
Okay, great, thank you. I just saw a comment from Dan Stein. For those of you who are Revit users, I know there are many, check out revitforum.org. He says there's a nice hardware test for Revit that he wrote that you can find there, revitforum.org, Revitforum, all one word. Yeah, that's great. Thank you, Dan. So, a lot of specific questions, again, just about individual setups. And I know you kind of have talked about that a lot. Robert, when you, I got distracted when you were talking about recap and the like. Were you able to address point cloud processing specifically? We had a couple more questions come in about that.
Well, I mean, basically what a point cloud is it is mapping of a surface. So you're essentially having, your GPU is essentially having to do a lot of computation and imply triangular panels between all those little dots in the point cloud. So it is a very GPU intensive function. Performance is dictated by a couple of things. Number one, it's the GPU that you have, but it's also how optimally architected the software is. For example, if you look at point cloud handling in AutoCAD, over the last 4 to 5 releases, it's gotten substantially better, substantially faster. So, 2 or 3 years ago, you could have bought a really bang GPU and you really wouldn't have seen the difference, but now you do. So it's only worthwhile buying the higher, more expensive GPU if the software is really optimized to take advantage of it. At that point, what I recommend you looking at is the software manufacturer's recommendations for which GPU cards they'll warranty is working. That's another excellent place to go out and look at some of the user forums and do some Google searches to see what you can find.
Okay, thank you. Can you touch on power supply again, and how folks can make sure that if they do go with a discrete GPU or more than one, that they're going to have adequate power supply to cover that in the system as a whole?
Good point. So if you're looking at a new workstation, chances are you're online and you're building some sort of a configuration that you're interested in. Probably the easiest way to do it is to just go in under the GPU selection and pick one of the really expensive big boy GPUs, probably more than you need, but go ahead and select it. And what will happen is if you select a GPU that is either going to require more slots or more power supply than that workstation can offer, it will alert you. So I know if I go in and do that on a Dell website or an HP website or a Puget website, they'll all tell me, this graphics, this GPU is not supported by this unit's power supply. That's the very easiest way to figure it out. I will just tell you, generally speaking, I'm a fan of get the bigger cabinet, get the bigger chassis, get the bigger power supply, because we're all going towards more powerful appliances and GPUs in the future. It's not just will it work today, but will it work in the future. So that should give you a couple of tricks for making sure you don't buy too small today.
Okay, thank you. This question is specific regarding Lumion rendering versus the rendering that's done in Revit, and I think in terms of, does that, if you're doing one or the other, does that affect your choice of single versus multiple graphics cards? In other words, if you're just doing rendering in your CAD program versus a full-fledged solution built for rendering, what should you be thinking about again?
Yeah, that is one way to tackle it. If you're using rendering that's supported, let's say it's just in a different process window and it's spawned from your CAD tool, then you're probably going to use a singular GPU and it's just supporting multiple processes. But if you do have one of these really high-end video editing tools or a really high-end rendering tool, yeah, that's one way to go, is to get a second GPU and allocate that GPU to that application. That way you can have a kind of a lesser expensive GPU that supports the CAD tool, and you can just put in a higher power one that supports the video tool. And again, check the software documentation so you make sure that you've got the right protocols and drivers that you'll be needing, and cross-check that against the GPU you're looking at buying.
Excellent. All right, we are at the end of our time here, folks. And so with that, Robert, if I could just get you to flip to that last slide. Thank you very much. We are officially out of time, so please, if you're still with us after the presentation today, go to cadalyst.com/rgwebinar, or RG webinars should work also. We've been having a couple, we had one person say they had trouble with one of those, but either way, it should work. It's working for me. That is a landing page where we're collecting all the slide presentations and recordings of Robert's webinars as we go along. The slide deck for today is already there. The recording will be there within 24 hours. We'll also send you an email when the recording is ready. If you registered for today's presentation, you'll get that email automatically. We also have some other great resources on that page related to Robert's work, to workstation configuration, all kinds of stuff there that I encourage you to go check out. So a big thank you to you, Robert, for another great presentation today. And thank you to all the attendees for your time and your interest. We appreciate it very much, and we hope you enjoyed this event. Have a great day.
Bye, everybody.